All right. So you have always two hypotheses, HO and HA. This is step number one, guys. Then step number two, you find the test statistic. It's either the Z or a T. A Z, when sigma is known, you use a Z test. And when sigma is not known, you use a T test. Then step number three, you find the p-value. Please pay attention to the last part. After you find the p-value, you compare it with alpha. If p-value is less, alpha is a level of significance. It's given to you. If it is less than alpha, and for the assignment, this is what I'm asking you guys to show all 5 steps. You reject HO. And if the p-value is more than alpha, you fail to reject HO. Now, step 5, write the conclusion. Conclusion in words. And let me show you guys the 4 scenarios and how to select the conclusion. I included them under resources by your instructor when you check the chapter 7 calculator handouts. You will see the 4 scenarios that you always have to select one of them, but I'm gonna go over them. Okay, if the claim is in HA, in the alternative. Now, probably a question you ask me, how do I know the claim in HA? It's obvious. If he tell you test the claim that the mean is more than 15, greater than 15 falls in the alternative hypothesis, so then you know the claim is there. So if the claim is in HA, there are 2 scenarios. Either you're gonna reject HO or you're gonna fail to reject HO. And let me tell you what you write in each case. If you end up rejecting HO, guys, that means you're saying that this is bad. No good, you reject it. And your claim happened to be in HA, you support the claim. So you write, there is enough evidence at the alpha, whatever alpha is, we write it down, level of significance to support the claim. To support the claim. And then you write what the claim is, that the mean is more than 15, blah, 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 whatever the claim is. So if you reject HO, if you fail to reject HO, what do you say, guys? Okay. My claim is in HA. So remember, the claim is still in HA. It's both cases here. My claim in HA, and I'm saying HO, I cannot reject it. So probably HO is good. So if HO, there is possibility to be good because we couldn't reject it, that means we cannot support HA. So you say there is not enough evidence to support the claim. There is not. So remember, guys, what I said last time. Every time you have the word not, fail, you have to start with not. Enough evidence to support the claim at the alpha level of significance. So these are 2 scenarios. I told you there are 4 scenarios, guys. Let me show you the other 2. If the claim happened to be in HO, in the null hypothesis, and you reject HO, what do you say? Okay, this is HO, and this is HA, and the claim is here. If you reject HO, guys, and the claim is in HO, you reject the claim. So you say, there is enough evidence to reject the claim. This is scenario 3, guys. So you have only 4 scenarios. You always choose one of them. Scenario 1, scenario 2, scenario 3. Let me show you what scenario 4 is. If you fail to reject HO, that means the p-value is more than alpha, and your claim happened to be in HO, that means you cannot reject the claim. So you say there is not enough evidence to reject the claim. See the not with fail, not enough evidence at the alpha level of significance to reject the claim. And then you say what the claim is. So in summary, guys, let me show you something. Probably that will be a good hint for you. If the claim is in the alternative hypothesis, you say there is enough evidence to support, or there is not enough evidence to support. Notice I'm using the word support here when the claim is in HA. But look, when the claim is in the null hypothesis, I'm either saying there is enough evidence to reject. I don't use the word support. It cannot be used here. Or there is not enough evidence to reject. Remember, guys, when you say there is not enough evidence to reject something, it doesn't mean you accept it. So don't change it to your own language and say, I accept the claim. You just say, I cannot reject it. We don't have enough evidence to reject the claim at the alpha level of significance. So if the claim is in HA, guys, you have only two scenarios to choose from, depending whether you reject HO and fail to reject HO. And if the claim is in HO, you have only two scenarios, 1 and 2. So you guys, if you want, just you can copy, paste, take a picture of this, because these are the 4 scenarios that will be used everywhere in any hypothesis test. You have to select one of the conclusion there. Any questions, guys, before I proceed to some exercises and do some more, in particular section 7.4, which is the proportion test. Any questions? Okay, that's so keep this handy, guys. I would take a picture of that screen right now if you want it, just to keep it handy and refer to it, because always when I make my final decision, I'm going to select one of those 4 conclusions. It all depends on where the claim is and whether I reject HO and fail to reject HO. If you comprehend this, guys, you're going to see that things for this week and next week are going to flow in very, very smoothly. We'll get to the critical value later. I'm just going to do a couple examples, and so you can do this exercise. All right. Let's go back. Have your calculator handy, guys. We're going to review 7.2, 7.3, and then we'll go to 7.4. The standard for this is the additional exercises from chapter 7. This is section 7.2. Okay. Section 7.2, guys, sigma is known. Population standard deviation is known. The Center for Disease Control, CDC, reported on trends in weight, height, and body mass index for 1960 through 2002. The general trend was that Americans were much heavier and slightly taller in 2002 as compared to 1960. Both men and women gained approximately 24 pounds on average between 1960 and 2002. In 2002, the mean height for men was reported to be at 191 pounds. Suppose that an investigator hypothesizes that the weight are even higher in 2006. So in 2002, they say the average weight was 191, but now someone is making the claim that they are higher. So what would that be? How would you write the null in the alternative hypothesis, guys? That means the mean is what? What would you say, guys? Yeah.
Greater than?
Greater than. You have this material, guys, and I'm going to scan him anyway this afternoon. So that's the claim. Oh, 191, sorry, not 192. And then the null hypothesis, guys, you remember, it has to be one of those signs. So it will be less than. Okay, if I take you back now, guys, to this, and look at that. I am here, my claim is in HA. My conclusion is gonna be this or that. If I reject HO, this is my conclusion. If I fail to reject HO, guys, that's going to be my conclusion. It's as simple as that. Why is that? Because my claim is in HA. If my claim is in HO, I would have told you that you have to choose one of those two. I'm going to leave this handy and show you how I can use it. All right. In order to test the hypothesis, we select a random sample of American males in 2006 and measure their weights. Okay, so they did select N equals 100. The average weight was from the sample was 197.1. And look what he writes here, guys. He writes sigma is 25.6. Sigma means the population standard deviation. For you guys, it means that you have to use the z-test. Z is sigma, normal distribution, standard normal distribution. So you must use the z-test. And now it's a calculator matter to do step number 2 and step number 3. I'm not gonna go over the writing here because that's what I'm explaining that now verbally. So have your calculator, guys, with the z-test, and let's perform the test, get the test statistic and the p-value, and see if the p-value is less than alpha or more than alpha. Let me grab my calculator. All right, there's my calculator, guys. Stat, tests, z-test number 1. I have a summary, so stats. Okay, mu 0, we're testing against 191. Sigma, which is 25.6. X bar, 197. N is a large sample size, it gave us 100. Now, before you hit calculate, guys, you choose the alternative sign. The alternative sign is greater than. So I'm choosing greater than. And then hit calculate. There you go. So Z is 2.34, and the p-value turns out to be on the small side, 0.0095. All right, that's all I need, step 2 and step 3. So Z is 2.34, and the p-value is 0.0095. All right. The p-value here, guys, is less than alpha. Alpha, what does he give me? Alpha. He says use 1%, for example, for alpha. Okay, so the p-value is less than alpha. What's the decision, guys? Do I reject HO or fail to reject HO?
Reject it.
Reject HO. All right, let me show you guys. Just to prove the case. There you go, watch. I'm not gonna do anything beyond what I told you. The claim is in HA, and I reject HO. Look what I say. There is enough evidence at the 1% level of significance to support the claim. That's it. And whatever the claim is. So there is enough evidence at the 1% level of significance to support the claim. And then you select what the claim is if you were doing it online. If not, here's the claim if you want to write it down. That the weights are even higher in 2006, that the weights of males are higher in 2006. That is the claim. Okay, so that is one question. Another one on section 7.2, sigma known, guys. Let's do this one. The EPA reports that exhaust emission for a certain car model has a normal distribution with a mean of 1.45 grams of nitrous oxide per mile and a population standard deviation of 0.4. You see population standard deviation, so that's sigma. The car manufacturer claims their new process reduces the mean level of exhaust emitted for this car model. So the emission is, the average emission is 1.45, but a new car maker is making a claim that they can reduce the exhaust emitted for this new car model. A simple random sample of 31 cars, so that's N, guys, is taken, and the mean level of exhaust emitted for this sample, is referring to the sample, is 1.121 grams. Can you guys tell me what the null and the alternative hypothesis? It's about the mean. Okay, they claim, look guys, read here, their new process can reduce the mean level of exhaust emitted. What do you think the claim is going to be? Can you guys help me with this? Let me see. Less, yes. The mean is less. Reduce means less. And the alternative, what's the complement sign to this? It will be that. And that's the claim. All right, it's a z-test, guys. Why z-test? Because he gave me population standard deviation. Okay, watch. Stat, tests, z-test. Stay away from the light. Okay. Mu0, we're testing against 1.45. Sigma, 0.4. X bar, 1.21. N, 31. We want to check if it is less than. There you go. You see how I selected less? And then I'm going to do a draw here, guys. Oh, it didn't show any p-value. It should be on the left because the p-value is very small. So let me write Z and the P. And I'm going to write the P as is. It's not 4. There's E minus 4, guys, there. So Z is negative 3.34. And the p-value is 4E minus 4. Let me tell you what that means. You have to move the decimal point 4 digits to the left, so it will be 0.0004, which is for sure, guys, it's less than alpha, and I don't even need to know what alpha is, which is 0.01. So what's the decision? P-value is less than alpha. We reject HO. Okay, guys, I'm going to take it to my yellow sheet one more time. The claim is in HA, and we reject HO. Then you support the claim. There is enough evidence at the alpha level of significance to support the claim. There is enough evidence at the 1%. You can put 1%, you can put 0.01 level of significance. The level of significance, guys, is the probability of making type 1 error, maximum allowable probability to make type 1 error. At the 1% level of significance to support the car manufacturer claim. That, let me see what the claim is. That their new process reduces the mean level of exhaust emitted for this car model. You just copy it, cut and paste. All right, so this is another exercise. Now for section 7.3. Testing a claim. This is very, very important section when sigma is not known, guys. Testing a claim about the mean sigma not known. When sigma not known, he's going to give you S instead, and it's not going to be a Z test, it's going to be a T test as we talked about last time. So let's continue doing some more exercises. The amount of water consumed per week by Montana residents is normally distributed with unknown mean. A simple random sample of 26 residents, so N is 26, guys, has a mean value of 120.3. X bar is 120.3. And a standard deviation of 10 gallons. You see, he didn't say population standard deviation. He's talking about the sample. So you make sure to put S here. S is 10 gallons. The city of Bozeman claims that the average water consumed in the state of Montana is not 125 gallons. Would a student please tell me what the null and the alternative is? I'm ready to get not equal. Yes, you are correct. Not equal 125. This is the claim. Okay, let me take you to the yellow sheet. Just show you how important the yellow sheet is today. So we decided that the claim is here. Now, maybe you're wondering, we haven't had anything right here. Yes, guys, we haven't had anything yet, but it is possible. So the claim is in, most of the time, the claim is in the alternative. In real life, it's here. But you're going to see in the book that there are questions where the claim falls in the null hypothesis. So the claim is here. So my conclusion, guys, is going to be, if I reject HO, it's going to be this. If I fail to reject HO, it's going to be that. Just one of the two. That's why I told you guys, take a picture of this and refer to it anytime as we do this. Okay, because S is given, this is a t-test. And let's do the t-test, t-distribution. Number 2, guys. Okay, mu0, we're testing against 125. X bar, he says it's 120.3. Standard deviation, he says it's 10. N, how many did we take? 26. And different from, you see how I select different from? And if you want me to hit the draw, let me do a draw here. Oh, there is a little bit of, you're gonna see p-value shaded on both sides because this is a two-sided test, two-tailed test. So T, guys, is negative 2.397. You have to do 3 decimal places for this. And the p-value, okay, for now is 0.0244, which I will demonstrate the critical value, right, in a second after I'm done with this. Okay, what's your decision, guys, at the 0.01 level of significance? Let's see what some students are saying here.
Fail to reject.
Fail to reject, yes. It's more than alpha, guys. Comparing. If you have any issues comparing those decimals, please let me know, especially during office hours. I'll support you. So you fail to reject HO. Okay? Good. We always end up rejecting. Now fail to reject. Let me go back to this. Your claim is in HA. I'm just trying to make things, simplify things on you guys. That's why I keep referring to this. Your claim is in the alternative hypothesis, and it's not this. You fail to reject this. So you say there is not enough evidence to support the claim. As simple as that, guys. Every time you fail to reject the null hypothesis, you start with there is not. I'm going to capitalize this so you know there is not enough evidence at the 1% level of significance to support the claim that the mean water consumption is different from, just copy and paste the claim, guys, is different from 125 gallons. All right. How would you use the critical value approach to do this? I'm going to show you that in a second. Let me show you how you could have done this question using the critical value approach. The p-value approach, guys, means comparing probability with probability. You compare the p-value with alpha. The p-value, guys, is the area to the left or to the right of the test statistic. So it is a probability. And alpha is a probability. So you are comparing oranges with oranges. The critical value, guys, is comparing numbers with numbers. So you want to compare t, the test statistic, with another number on the number line. This is what the critical value. So let me sketch this one and show you how you could use the critical value approach. So either oranges with oranges or apples with apples, but not oranges with apples. You cannot do that. So this is what the p-value approach, and here is how we could do the critical value. And the critical value, it's always, he will ask you to sketch a curve. So if we were to use the critical value approach, you do this, you do that, which is step number 2. And the formula for this one, guys, it's x bar minus the mean divided by s over square root of n. X bar here, it's 120.3, or you could still use the t-test to find it. It's no problem. Minus the mean, which is 125, divided by s, which is 10, over square root of 26. If you do the math, guys, you're going to get negative 2.397. But please watch and see how the critical value works. You draw the curve, decide. This is a T. Is it a right or left or two-tailed test? It is a two-tailed test. So it's right because how do I know it is a two-tailed test? Because this is not equal to. So you just shade two area to the left and to the right and put a number here, which is called the critical value, CV. We call it in section 7.2 Z sub 0, but because it is a T here, we call it T sub 0. One is going to be positive and one is going to be negative, guys. And this is called the critical value. Let me show you how to find this critical value. We can either use the calculator or we can use the table. Here is table 5. You're going to help me finding this one right here. This is the table of critical values. We don't look at this level of confidence. We're done with this. We're going to do hypothesis testing. Now, you guys, do you agree with me that this is not one tail, it's a two tails? So we look at this. It says two tails, different from. What is alpha in this exercise? 0.01, I believe. So we're here. So two tails and 0.01. N is 26. What is the degrees of freedom, guys, for this particular exercise?
25.
25. Excellent. Watch, guys. Okay, I'm going to mess this up. It's okay. Okay, they met right here. And I think I can hardly read it now. It's 2.787. 2.787. And notice, guys, I didn't use the one tail row. I used the two tails row because this is a two tails test. I selected the 0.01. I selected the 25. I draw a vertical line, horizontal line. You can use a pencil here to trace it. And then I got this one, 2.787. And look now how easy it is to make the decision. So this is 2.787. This is negative 2.787. Okay. Now we need to decide whether we reject the null hypothesis or fail to reject the null hypothesis without this. So assume, guys, that this is not there. We don't have it. We're doing the critical value approach. Look what you do. Here is the test statistic. The area to the right of the critical value and the area to the left of the critical value are the rejection regions. This is where we reject the null hypothesis. So let me take the negative 2.397. Do you guys agree with me that it's going to fall somewhere here? Yes, because it is more than negative 2.787. So it didn't end up in the rejection region. So what would be the decision in this case? Fail to what? Reject HO. And this is how you make a decision. So what's the critical value, guys? You use the table to put the critical value. If it is a left tail test, you put the critical value on the left and you shade to the left. If it is a right tail test, you put it on the right and you shade to the right. If it is a two tail test, you find it and you put it on both sides. Then you go back to step number 2 and place the number on the number line. If your number falls in the rejection region, you reject the null hypothesis. If it doesn't fall in the rejection region, just like in this one, you fail to reject the null hypothesis. For example, if this guy's was negative 3, where would negative 3 be? It will be here. And then you would reject the null hypothesis. So it depends on what your test statistic. And you notice here, guys, I'm comparing a number with a number. Whereas with the p-value, I'm comparing a probability with a probability. They're exactly the same way, but the p-value is more modern method. You can use technology to find it. This one, you need to use tables in order to find the critical value. That's why I ask you to focus on the p-value approach, but I would like you also to know that the critical value method exists as well. That's why I left only one example in there with the critical value. Any questions? I'm going to do another one as we progress. Oh, how do you find it on the calculator? That's a good question. Okay, critical value on the calculator. Let me do it in the next exercise. I'll do it in the next one. 3. A credit company wondered whether giving frequent flyer miles for every purchase would increase card usage, which has current mean of 2,500 per year. They gave free miles to a simple random of 24, and is 24, and found the sample mean to be 2542. And look, guys, it says with the sample standard deviation. Don't make it sigma, that's S, 109. Okay. Can you guys tell me what the claim is? A credit card company wondered whether giving frequent miles for every purchase would increase the card usage, which is currently at $2,500 per year. All right, I'm waiting for suggestion. What do you guys think they want you to test? Any suggestion?
More than 2,500.
More than 2,500, that is correct, because increases, yeah, 2,500. That's the claim. 2,500, that's the null hypothesis. And if I go back again, guys, to my yellow sheet, you're again here. If you reject HO, you're gonna select this language. If you fail to reject HO, you're gonna select the other language. Okay, it's a t-test, guys, because S is given, it's a t-test. So let's run the test. And then I'll show you how to do it with a critical value approach as well. So stat, tests, t-test. Okay, we're testing against $2,500. X bar is 2542. S is 109. N is 24. And then we're testing that the mean is greater than, this is the alternative hypothesis. And if you like me to hit that draw, I can do that. Or calculate it, it's up to you, it doesn't matter. Not much shaded. Oh yeah, it is shaded. So test statistic is 1.888 and p-value is 0.0359. Okay. Okay, he wants us to test at alpha, so that's bigger than alpha. So decision is what? Fail to reject HO, guys. And because I failed to reject HO, I'm going to select this language. There is not enough evidence to support the claim. Enough evidence at the 1% level of significance. Don't forget this one to support the claim. Okay, critical value approach. The only difference in the critical value approach is step number 3. Here you use p-value. Step number 3 is going to be critical value. Look what you do, guys. Draw a sketch. Okay, put a 0 here in the center. Put a T. Okay, you guys agree with me? This is a right tail test. How do we know if it is a right tail test? It's from the alternative hypothesis. If it is greater than, it's a right tail test. Less than, left tail test. Not equal to, is a two tail test. So shade something area on the right and call this one T0, the critical value. Okay, I'll do it using the table and then I'll show you how to use a calculator here. Okay, I have N is 24, so we need degrees of freedom 23 and alpha is 0.01. But watch, guys, I'm gonna be using one tail here because it is a one tail test. So 0.01, I'm right here. You see for two tails, the 0.01 is here. So I'm gonna use this and then 23. Okay, what is that? 23 right here. And 0.01. And I'm right here, guys. It's 2.5. I'll just select that. Okay, remember, we failed to reject the null hypothesis, so we better be able to do that even with the critical value. What is T? T is 1.88, and you guys agree that T is right here. It didn't fall in the rejection region because T is less than 2.5, then you fail to reject the null hypothesis. Let me see, any question? Yes, you determine the tail based on HA, exactly. Not on HO, never, it's on HA. So you see, guys, T is 1.88, it didn't fall in the rejection region. This is the rejection region right here. Then you fail to reject the null hypothesis. How do you do it using the calculator, guys? Very straightforward. Watch. You go to second and distribute inverse T. For inverse T, you need two things. The area to the left, and the degrees of freedom. Well, this is alpha. You always shade alpha, guys. So alpha is 0.01. What would be the area to the left of 0.01? If this is a 1%, so that's alpha. That will be 1 minus alpha, which is 99%. So if I put, guys, 0.99, I mean, you can leave it as 0.01, but you're going to get a negative number, so make it a positive. That would work as well, but let me just do it properly. So inverse T, 0.99, comma, degrees of freedom 23, guys. There you go, 2.4998. If you round it, it's going to be 2.5. That is the critical value. But look, if you keep the 0.01, it's okay, not a big deal. Comma, 23. Watch. You get negative 2.5. But you know, guys, you are working on the right, so you cannot put a negative. It must be positive. So this is the critical value approach. Okay, number 4. A fast food outlet claims that the mean wait time in line is less than 3.5 minutes. A random sample of, so it's easy to get the claim here, less than 3.5 minutes. Oh, again, the claim happened to be in the alternative. I'm not saying it is always the case, guys. We will come across some other exercises. A random sample of 15 customers, so N is 15, had a mean X bar equals 3.4 minutes, with S standard deviation to be 0.6 minutes. At alpha equals 0.05, test the fast food outlets claim, not using confidence interval, just using p-value. All right, let's do this right here. I'll write them down again, guys. That's the claim. Make sure to label the claim so you know how to refer to it when you're done. All right. Find the test statistic. So it's a t-test, stat, t-test. Okay, mu0, we're testing against 3.5. X bar, I have a 3.4, guys. And S, I have 0.4. N, I have 15. And you know it is a less than. Calculate. There you go. So T is negative 0.968, and the p-value, oh, it's a huge. .1747. Make a decision to reject HO or fail to reject HO. Alpha is 5, guys, so this is bigger than alpha. So you fail to reject HO, the null hypothesis. Okay, let me go back to your favorite sheet for today. You're claiming HA. Again, we're still here. You fail to reject HO, guys. What do you say? There is not enough evidence to support the claim. Enough evidence at the 5% level of significance to support the claim. All right. Now, guys, for the next one, I'm going to pause for 1 minute and have you key in the numbers there, please. Number 5. So just do that, and I'll do it. All right. So it's a t-test, guys. But it's not going to be stats anymore. He gave me raw data, so it's data. And we are testing against 3.5. So this is 3.5 right here. Oh, no. Sorry. I'm looking at the previous exercise. Carolina Tobacco Company advertised that its best-selling non-filtered cigarettes contain at most 40 milligrams of nicotine. But Consumer Advocate magazine ran tests of 10 randomly selected cigarettes and found that the amount to be the following. It is a serious matter to charge that the company advertising is wrong. So the magazine editor chooses a significance level of 0.01. Can the editor prove that the mean nicotine level is greater than 40 milligrams? So you guys should agree with me that the claim is the mean more than 40 milligrams. And this is the sign right here. Assume that nicotine levels are normally distributed, and let's run the test. It is a t-test again. So you guys, if we test in the mean, it is always a t-test unless if he gives you sigma. If he gives you sigma, you run z-test. Otherwise, it's always a t-test. I know it's tempting when you hit tests, you see the z-test first to use it, but it doesn't mean this is the more popular one. The t-test is the one. So data, okay, we're testing against 40, correct? And my data is in L1, good. Frequency, don't change it at all. We need to test that the mean is greater than mu0, which is 40. You see the 4 I put here, we're testing against it. And I'm gonna hit calculate this time. It's faster. Okay, T is 2.746. And look at the p-value, guys. And the p-value is 0.0113. Make a decision at the 1%. Okay, you guys should agree that the p-value is more than 0.01, which is alpha. It's a little bit more, almost very close. So you fail to reject. Fail to reject. HO. What is the conclusion? According to my yellow sheet, there you go. We failed to reject HO. We're still here. Haven't got any exercises where the claim is in HO. You fail to reject HO, you don't support the claim. So the editor is making a false claim, guys. That's serious. So there is not enough evidence to support the claim. The tobacco company can go back and sue the editor because he could not prove his case. Now, section 7.4 is not about testing the mean, it's about testing the probability, the proportion. So this is section 7.4. That should be on the next page, but I don't know how it ended up at the bottom here. So let's go and continue working with this and show you guys how to work with this section. Okay. The engineering school at a major university claims, you see it percents, now we're talking about percents, no mean and standard deviation anymore. They claim that 20% of its graduates are women. In a graduating class of 210 students, 46 were women. Does this suggest that the school is believable? So this is just like the proportion Z interval, guys. It is about the proportion. It's not about the mean anymore. Would a student please tell me what do you think the null and the alternative hypothesis should be? They claim that 20% of their graduates are women. That's the claim. How would you state this?
P equals 20.
Yep, you got it. And the good news is, guys, this time the claim happened to be in HO because I need to show you how to use the last two conclusion when the claim is in HO. So good, we have it in HO. Okay. This is a proportion test, guys. If he asks you to verify the requirements of the test are met, you do the following. So requirements. If he doesn't, when you do your work online, you just proceed, guys, to the test and do the steps. The requirement, you have to check that n times p is greater than 5 and n times q is greater than or equal to 5. N is this. And x, guys, is the number of successes. So he will give you always n and x. That's all you need to run the test. To check if np greater than 5, you do the n 210 and multiply it by this number always. Well, guys, this is bigger than 5 if you do the math. That is bigger than 5. Now, q, look what you do. You take the 210. Q is the probability of failure. So if it is 20% here, it will be 80% there. And if you guys do the math, definitely this is going to be bigger than 5. So we're good to run the test. If these are not verified and they're not met, you cannot proceed with the test. But if he asks you to perform the test, that means he's assuming that the requirements are met. Okay. In order to do this, we use a test. It's called one proportion Z test. And let me show you what number is this right here. So go to stat, tests. It is number 4, guys, not number 4, number 5. So take a note, that's number 5, one proportion Z test. It's not a Z test. Z test is for the mean. It's not a T test, it's for the mean. The proportion, it says a prop. Prop means a proportion. And very easy test to process, guys. Watch. All you need to enter the value from the null hypothesis, 0.2, and just enter x and n, and you're all set. X is always the smaller number, so that's a 46. And n is the bigger number, 210. And we are testing that the p is not equal to, not the alternative is not equal to, I'm sorry. And then calculate. Okay. Z is 0.69. P-value is 0.4902. Oh, it's a huge p-value. Bigger than alpha, you fail to reject HO. And if they ask you why, because the p-value is more than alpha, and interpret your decision. Okay, guys, watch here. Great, I'm here. The claim happened to be in HO. And I fail to reject HO. What do I say? There is not enough evidence at alpha level of significance to reject the claim. That's how you write it down. There is not enough evidence at the 0.05 level of significance to reject the school, the engineering school claim. That 20% of its graduates are women. Does this mean that the school is believable, guys? What do you think? We could not reject their claim. Does it mean that they are believable? Because that's a question here. Does this suggest that the school is believable? Yes or no? Yes. Because we could not reject their claim, so probably they are believable. If you can't reject their claim. All right. Next exercise, proportion Z test. Any Boston Celtics fan or archival knows that Shaquille O'Neal, one of NBA's most dominant centers of the last 20 years, always had difficulty shooting free throws. Over the course of his career, his overall made free throws percentage is 53.3%. That's the successful one, guys. During this offseason, Shaq is working with an assistant coach on his free throw technique. During the first 5 games of the next season, Shaq made 26 of his 39 free throws attempts. Do the results provide convincing evidence that Shaq has significantly improved his free throw shooting? Carry out a significance test at alpha equals 0.05 level. Would a student tell me what HO and HA? It's about the percentage, guys. Once they start mentioning percentage, it is about the percentage. What do you think? We want to help him. The trainer, the coach is helping him improve his previous percentage of free throws, which is 53.3%. So what do you think the null and the alternative will be?
Would it be equal and not equal?
You want to improve something. You want to improve your percentage, meaning if I tell you got 70% on the test and I want you to improve it next time, what is it I mean by improving?
More than?
More than, exactly. So this is 533, that's the claim. Now we're not saying that it did happen, we have improvement, that's why we need to test it. Now the reason why I put 0.533, guys, this is how you change the percent to a decimal. Okay, look, 2639, so n is 39 and x is 26. This is all you need, and alpha is 0.05. Let's run the test. Stat number 5. I'll bring my color screen calculator for tomorrow's lesson. All right, so P is 0.533. X is, what was X? 26. Let's see if there is improvement. 39. Okay, greater than. And let's hit calculate faster, guys. So Z is 1.67 and the p-value is 0.0471. Good. You notice, guys, the redundancy and what I'm doing. I told you once we do 7, it's always going to be the same thing, which is, guys, less than alpha, less than 5%. So you reject HO. And the claim in HA, I'm back to here. I'm here. Reject HO. There is enough evidence to support the claim. There is enough evidence at the 0.05 level of significance to support the claim. I'm not going to write the rest, but I'm going to read it. That Shaq has significantly improved his free throw shooting. That is the claim. So it did help. Yes, we do support the claim. Next question. 8. A drug manufacturer claims that fewer than 10% of patients who take its new drug of treating Alzheimer's disease will experience nausea. Can you guys help me state the null and the alternative hypothesis here?
P less than 10.
%. That is correct. Or you can write 0.1. That's the claim. 0.1. Great. In a random sample of 250 patients, so N is 250, 23 experienced nausea. Perform a significance test at the 5% level of significance. I hope that the stuff is making sense to you guys now. So let's run the proportion Z test. Here you go. Stat. Okay, 0.1. I never tried to put 10 here. I don't know if it will work. It will recognize that as 10%. You can try it. I'll try it later. X is 23. N is 250. And we're testing that P is less than P0. You like to see a draw here? Let me do a draw. It's going to draw the p-value for you. Oh, it's huge. So Z is negative 0.42. This is not the critical value that you see in the calculator. It's the p-value. The calculator is capable of drawing the p-value. The p-value, guys, is 0.3366, which is more than alpha for sure. So you fail to reject HO. All right. If we fail to reject HO, what do we say, guys? There is not enough evidence at the 10%, not 10%, 5% significance level to support the claim that fewer than 10%, you just write it down, fewer than 10% of patients who take it's a new drug for treating Alzheimer's disease will experience nausea. That means we cannot support the claim. The claim probably is not valid. All right. And one more. 9. Just want to do enough with this section so you can You can go back and get it done. It was found that 821 crashes of mid-sized car equipped with airbags, 46 of the crashes resulted in hospitalization of the drivers. So you guys, you would agree with me that N is 2821 and X is 46. Using a 0.01 level of significance, so alpha is 0.01. Test the claim that the airbag hospitalization is lower than the 7.8% rate for cars. Well, guys, lower means less than. So HO, HA. P is less than 7.8%. Change it to a decimal. It will be 0.078. That's the claim.
Really?
0.078. All right. So run the proportion Z test. Let me just write down here what we did as well.
Julie. Let's see.
All right, proportion Z test. And you guys, let me show you the calculator screen again. And one more thing, I want to make an observation in this question. Please pay attention to it. It is important. So let's go stat, prop, Z test. Okay, we're testing against 0.078. Then X is 46. X is a smaller number always. 821 less than. All right, and let's hit calculate. So Z is negative 2.35. Watch, guys, and the p-value is small, as you can see. 2 zeros with the p-value, then you're gonna reject the null hypothesis. 0.0095, which is for sure less than alpha, guys. Reject HO, and then if you reject HO and the claim is in HA, support the claim. There is enough evidence at the 0.01 level of significance to support, if you go back to the yellow sheet, to support the claim. That airbag hospitalization is lower than the 7.8% rate for cars with automatic safety. Now, guys, I want to show you that he could reward the problem in a different way, and I just want to make sure that you understand what to do when you use the calculator. So let me change something here, just 1 second. Okay. It was, look, he could reward the problem the following way. It was found that 821 crashes of mid-sized cars equipped with airbags, 60% of the crashes resulted in hospitalization. So there is no 46 here. He put 6% here. Using the 0.01 significance level, test the claim that the airbag hospitalization is lower than the 7.8% rate for cars with automatic safety. What would you do, guys? You are required to input X and N. If you look at the proportion Z test, look again. You need P0, which is the value from the null hypothesis. We assume the null hypothesis is true until proven otherwise, and you need X and N. So do you guys know what to do here? Instead of 46, he put 6%. What would you do to find X? Any ideas? %60 of the crashes. To find X, guys, look what you do. He's telling you 60% of the crashes. He didn't give you a number. So just compute this number. So do 60% of 821. That's what you do. So let's do it. See it, do it separately. Quit. 60% is 0.06 times, the number is 821. Okay. I got 49.26. Remember, X is a number of successes and it has to be a whole number, guys. So you round this number and make it 49. Either 49 or if it is closer to 50, you make it 50. So you just do 49. So when you go to your calculator, you go to stat, tests, one prop Z test, and P0 0.078. Here, I made up the 6%, guys, whatever. I could give you any number there. So you just put 49 in there. You don't put 49.3. If you put 49.3, it will not do it. Watch. I'm going to put 49.3 by mistake and see what happens. Domain error, because X has to be a whole number. It's number of success. It's a discrete number, so it doesn't work. So just, if you go back and fix it, watch. $49. It's gonna work beautifully now. There you go. You get. So if he gives you a percent, guys, most of the time probably he won't, but if he gives you a percent here to find X, so if P hat is giving instead of X, to find X, X will be P hat times N and round to nearest whole number. Make sure that you do that in this case. All right. All right. If you don't mind, guys, I'm just gonna go about 10 minutes above the time as we told you last time. So just 10 minutes, please bear with me. So that ends the discussion of section 7.4. And let me stop